Alright, hello again. Another flipped lesson for chapter 10 here. This is actually the one that's on the day that we have our first hour gone. So this is the whole reason why we're doing flipped lessons these first 2 days anyway. So anyway, it's going to be section 2 out of chapter 10. And so we looked at section 1 where we had like an intro to a bunch of basic circle terminology and tangents and stuff. So now those were like a lot of lines and segments now. So now we're going to be looking at arcs. And I want you guys to think of arcs as like being basically the same thing as an angle. And you'll see the relationship here pretty soon. So what we'll do is we'll go ahead and start out with one of our big T's, and that's going to be some terms. So if you're making a list of all of your terms for this chapter, then your ninth term here is going to be the central angle. And so when you have a circle and an angle within it where the vertex of that angle is at the center and the sides of the angle are radii of that circle, then you call that angle a central angle. So for this particular circle, we'll call it circle R in this case. In this example, a central angle is going to be angle, why don't you go ahead and try to fill it out before I do, but in this case, a central angle is going to be angle ARC. So this angle here is a central angle. A non-example, if you want a non-example, would be angle ASC. That is not a central angle, and that is because the vertex of the angle is not the center of the circle. So that's your first term. All right, I'm going to throw a bunch more terms at you here. Here's where we're digging into the stuff with arcs. So just to tell you what an arc is, basically it's just a section of a circle. So remember, a circle is the set of points that revolve around a certain point. So an arc is just a section of those points. But I wanted to throw in there, but that corresponds to a central angle. So keep that in mind. So an example, I mean, you've got a lot of examples of arcs here in this picture. Like I would say that arc AB. So if you see like the pink there, this little pink section, that's an arc. And we denote it with some notation here, like you do like a little curvy thing on top to make it look like an arc. I'm talking with my hands right now, just so you know. But anyway, you do a little curvy thing on top of your two end points of the arc, and then that denotes an arc. I mean, you can label a bunch of different arcs here, like for example, arc BD is also one. You know, that would be you could call it maybe the section from B to A to D. So this is actually kind of a non-specific one because you're not sure which way to go. So if I wanted to be specific about this one, I would probably have to give you 3 points there, such as like BAD, if I wanted to go from here to here. But if I wanted to go the other way, then I would have to say arc like BED, something like that. So when it's not clear, a lot of times you have to give maybe 3 points on that arc, but when it's pretty clear which one it is, when you have just AB, you take the shortest distance. And that's exactly what a minor arc is. So if you're seeing 2 points like labeled for an arc, you assume that you're going to take the minor arc, and that's going to be an arc that measures less than 180 degrees. So I didn't really define how arcs are measured beforehand, but that's kind of what I meant by corresponding to a central angle. So for example, the arc AB corresponds to this angle ACB. And clearly you can see that this angle right here is a lot less than 180 degrees. So if basically the arc measure is going to be the same as the central angle measure. So maybe write that down. That's going to be a theorem we'll see later, but for now just know that arc measure is the same as the central angle measure. So a minor arc is going to be an arc that has a measure of less than 180 degrees. And so then intuitively, a major arc is going to be an arc measuring greater than 180 degrees. And so an example of that would be like that arc BED that I pointed out here in blue. Now because if you ever want to denote a major arc, you're going to have to include like 3 points. Because, like I said, you always assume you're going with the minor arc if you just see 2 points. Alright, so then a semicircle is another special example of an arc, and that is going to be an arc that measures exactly 180 degrees. And so the name is pretty intuitive as well. Like, you've heard the word semicircle before. It's just half of a circle. Well, now you know that half of a circle has an arc measure of 180 degrees. So, in other words, a semicircle is an arc that shares endpoints with a diameter. So, technically, the angle BCE is the central angle for the semicircle. And obviously, since it's a straight line, it's 180 degrees. So, trying to tie this all together as much as we can. So, here are some examples. Like I said, AB is a minor arc. BD, I should put BED here. Arc BED is a major arc. And then BE is a semicircle. And since it's a semicircle, it doesn't matter which way I go, because if I go BAE, then it's still going to be a semicircle. So, those are some new terms for you. So if you need to pause it and maybe rewind a little bit, I know this is kind of new. Don't worry about it. So that's what these flip lesson videos are for. Otherwise, we're going to take a look at some more terms. All right, we've seen, if you watched the first video, you would have seen the term concentric circles thrown at you once. I didn't elaborate on it a lot, but essentially concentric circles are just going to be circles that have the same center point, but they're going to have different radii. Okay, so like I said, we saw some concentric circles earlier, and so here's an example of concentric circles. You've got 2 circle B's here, but one is smaller and one is bigger, obviously. So if I were to just say, hey, where's circle B, you'd need to know a little bit more information. So in this case, the small circle B has radius AB, and the big circle B has radius BC, and obviously AB is going to be less than BC in this case. But the idea here is that we've got concentric circles, same center, different radii or different distance from that center. And again, concentric kind of tells you exactly what those are. They share a center. They're co-centered. So looking at another kind of like the flip-flop of that, congruent circles are going to have the same radius measure but different centers. So these are just going to be circles that have the same exact size. So you could lay them on top of each other and they'd look exactly the same. But in this case, they have to have different centers, though, in order to be congruent circles. So in this case, we've got congruent circles if we know that this radius QS is equal to the radius TR. And so in that case, we would say that circle Q is congruent to circle R. Again, same radius, different center. Up here, we've got same center, different radius. All right, one more term. We've been looking a lot at arcs, so now we're going to take a look at the possibility of having congruent arcs. So arcs, in order for them to be congruent, first they have to be on the same circle and or on congruent circles. And so by definition, congruent arcs are going to be arcs with this stipulation that have the same measure. So they're just going to be arcs that are the same exact size. So for example, this one circle has 2 central angles that are the same. You can see that because they're vertical angles. So this arc LM corresponding to this angle here is going to be congruent to the arc ON. Alright, pretty easy to see there. And so then the flip side of that, we've got some other vertical angles, so that means that LO, that arc, is going to be congruent to the arc MN. Ergo. So, alright. Now to demonstrate maybe having congruent arcs on different circles, you can see here, okay, we've got some concentric circles going on again. We've got a little circle A and we've got a big circle A. So if I were to give you the fact that this radius PM is equal to the radius AC, so I gave you PM is congruent to AC, then that tells you that circle P is congruent to big circle A. Not little circle A, but big circle A. And so in that case, if you knew that, and I gave you another central angle that's equal to this one over here, so for example BAC congruent to LPM, then that makes that this arc from the big circle is going to be congruent to the arc from the other circle that it's congruent to. So that would mean that arc BC is congruent to these two pink ones over here. Now, take a look at little circle A where we've got DE, which technically has the same measure as arc BC, but it's on a non-congruent circle. So that means that arc D, and you can see that DE is not the same size as these other two pink ones. So the fact that it's on a non-congruent circle means that arc DE is not congruent to BC, LM, or ON. All right, getting into some theorems now. So the first theorem here is basically what I said when I first started talking about arcs. The idea behind measuring an arc is basically finding the measure of the central angle. And again, I want to stress the fact that the central angle, the one that you naturally look at, is going to be giving the measure of its minor arc. So remember, we kind of automatically go to the minor arcs unless someone specifies. So again, that's what this theorem is getting at. Measure of a central angle is the measure of its minor arc. All right. And then the other theorem I want you to know about is the arc addition postulate. And it's basically just saying if you add a little arc and another little arc, you get the whole big arc. And that's exemplified here where I'm saying, hey, take arc AB. So let's say I want to take arc AB, and then I want to add it to arc BC. Obviously, that's going to give me the measure of arc ABC. And the same thing for if I want to add arc BA to arc AD, and that's going to give me the whole measure of arc BAD. So now what I want you to do is I want you to pause the video and go ahead and try to fill in what you think the measure of each of these minor arcs are. And then I also want you to go ahead and fill in what the measure of these major arcs are after we used the angle addition postulate. Alright, so here are the solutions you should have had. Oh, and I took away those other ones. Because the arcs that we saw before actually just show up over here. So you can see that if you look at AC as a diameter, you can find this angle by subtracting from 180. So arc AB is going to correspond to that 35-degree central angle. I gave you BC, so that should have been pretty easy. And then DC is just the vertical angle of that, so it's going to be the same as AB. And then DA, same case. So those should have been pretty easy. Now, look, if you wanted to find these ones, you could have done it one of two ways. You could have added up these arcs from before and gotten your whole thing, or if you remembered that, you noticed that, hey, this AEC is a diameter, which makes the whole thing a semicircle, then you could have filled in 180 degrees for both of those. And I kind of gave this away on accident. I meant to erase it, but I want us to take a look at one more example where we want to add the semicircle AC, and then, hey, let's go ahead and tack on little arc CD here, because our big arcs don't have to be semicircles. So if I take my arc AC from before and then tack on another little arc CD, that's going to give me another big arc. In this case would be arc ACD. And so I would get that 215 degrees by taking the 180 degrees from arc AC and then adding the 35 degrees from arc DC, and that's where I get my 215 degrees. All right. So I've got one more test question example for you. Here I've got a figure where I gave you some central angles on this circle S, and I have a few arcs here that I want you to classify first as being major, minor, or semicircle, and then I also want you to give its measure. So if you want to go ahead and pause it now. All right. So here are the solutions. I would have filled in these angles first by, subtracting from 180 wherever I saw a diameter and stuff like that. And then I can use the angle addition postulate wherever I need it, or my central angle theorem. So as you can see, wherever I have less than 180, again, that's where I've got a minor arc. Wherever I have equal to 180, I've got a semicircle. And then wherever I have greater than 180, I have a major arc. So this should have been pretty straightforward. If you have questions about it, please come see me. Otherwise, we'll go ahead and practice some more stuff in class, and we'll have a homework quiz before we do that too. So make sure you're ready for that. See you tomorrow.